Okay, so we are now getting into three-dimensional geometry, which is a really important chapter because that's the world we live in. It's in 3 dimensions. So we're going to start first with talking about prisms, and then we'll go back and we'll cover cylinders. So your notes, you should have 2 pages of notes. Seems like a lot, I know, but it's because there's a lot of vocab in the beginning. We're going to just cover the prisms part first. Okay, so this part might be a little bit of a review, and based on the little picture you've got right here, you could probably fill in all these blanks. So it says 3-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face, as you can see right here. An edge is the segment that is the intersection of 2 faces. So this would be an edge right here, this would be an edge right here, and then of course this one is a vertex, which we already know what that is. So that is the point where 3 or more faces intersect. At that one point, we call that a vertex. All right, here we've got 4 different shapes right here. Let's see if you can recognize some of these. This first one is actually what we're going to talk about mostly today. This is what we call a prism. Okay, so in a prism, you always have 2 bases that are both congruent and they're parallel. Okay, the other faces are just what we would call the lateral faces. Okay, so right here we've got 2 bases, congruent and parallel. Next one here is very similar to a prism. We've got 2 bases again that are congruent and parallel, but the bases specifically are circles, so we give it a special name. This is called a cylinder. So these are the first 2 sections of the chapter that we're going to cover. These ones down here, not too concerned that you know the definition just yet, because we'll cover those later. But if you can recognize the shape, this one is a pyramid, and this one is a cone. Now in pyramids and cones, those just have 1 base, but we'll get to those later. Okay, and then I have a lot of kids ask about, well, what's a cube? Well, that falls under the category of a prism. So go ahead and fill that in your notes. That's just a prism that has 6 square faces. Okay, now if you look at all these shapes I have here, all these top ones I have in blue, those are all considered prisms. And we name a prism by the shape of its base. So in this case over here, the bases are triangles. So we call this a triangular prism. You can go ahead and write that down in your notes. Right here, we've got 4 right angles. We don't know if the sides are congruent, but in this case, we could call this a rectangular prism. And I have a lot of questions on this one, like how do you know which ones are the bases? When it comes to rectangular prisms, you could have multiple bases. You just have to pick 2 of them that are congruent and parallel. So you could pick the top and bottom. You could pick like the side ones here or front and back. So whenever you are dealing with, like you're finding area and volume and all that of prisms, I highly recommend you shade your bases. So like if I were doing this problem and I picked top and bottom, I would like fill in, let me just kind of show you real quick. Like if I had a worksheet, I would shade those in so I know which ones are my bases. That's going to be really helpful. Okay, moving on to the next one. So look at the base shape here. We've got 1, 2, 3, 4, 5 sides. So we have a pentagon. So this is literally called, well, the fancy way is a pentagonal prism. But I'm okay if you say pentagonal prism. That's fine. Pentagonal. The next one, that is a hexagon. So you could say a hexagonal prism or hexagonal prism is fine. All right, coming down here, if you look at all of these are all pyramids. Okay, they all have 1 base. And again, we name it the same by its base shape. So here would be a triangular pyramid. Next one would be a rectangular pyramid. Pentagonal pyramid. Last one, hexagonal pyramid. There you go. Okay, so in the previous chapter, when we dealt with area and perimeter of polygons, we were talking about 2-dimensional shapes. In 3 dimensions, we don't call them polygons anymore. They're called polyhedrons. Just an FYI there. Just means a solid figure with many faces where each face is a polygon. All right, a little bit more vocab. Go ahead and fill all this in. Let me just break this down. I mean, you don't have to memorize any of these definitions. You just have to be able to recognize when I use these words what I'm talking about. So for instance, I kind of mentioned this already. In a prism, you always have two bases. And then the ones that are not bases, we call the lateral faces. Okay, also, all of these are edges, but if I'm pointing to an edge that's on a base, it's literally called a base edge. If I point to one that's on a face, it's called a lateral edge. Okay, what else? Let's see. Okay, so typically we deal with polyhedrons that are straight up and down like this, and they're called, like, if it's a prism, it's called a right prism if it's straight up and down. Over here, if it's leaning, we call that an oblique prism. We don't deal with those ones as much. Typically, we deal with the right prisms. Okay, getting into the good stuff here, the important stuff. So in this whole chapter, you're going to be asked to find the lateral area, the total surface area, and the volume of each different kind of polyhedron. So it's a lot of formulas. There's a lot of formulas in this chapter, but I will provide the formulas to you. You won't have to memorize them for anything. Okay, you just have to be able to use them. So go ahead and fill all this in. Let's talk about what the lateral area is. So the lateral area is the sum of the areas of the lateral faces. So it's basically the area of everything except the bases. So in this figure here, it'd be the area of everything around, but not the area of the bases. It's like if you're in a room and you want to paint all the walls, that would be all the lateral area, right? Because you wouldn't paint the ceiling and the floor. Okay, so let's take a look at the actual formula for lateral area for any prism. In order to do this, you could actually take a prism and you could unfold it essentially, so you lay it all flat in like a two-dimensional figure, and you could find the area of all the faces, right? Excluding these two bases, if you pick those as the bases. If you do this, this is called drawing the net of a figure. So try to draw this net, actually. I'll show you the one I did. If you want to pause this, you can and try your own. They don't have to look identical. This would be one way you could draw the net of this shape. Unfolded, laid out, it would look kind of like that. Of course, I mean, you could put this rectangle over here or over here. You've got some options there. Okay, so lateral area for a prism, go ahead and give you that formula. Go ahead and write that down. I do L for lateral area. Some teachers do LA for lateral area. I just do L, so it doesn't look like L times A. Okay, so lateral area is the perimeter of the base, which I write as capital P, times the height of your figure. Okay, and this is important to write right here, what those letters represent. Because I have a lot of kids come test time get kind of confused whenever they see P for perimeter, because there's a lot of different perimeters you could find. It always means the perimeter of the base. Okay, and then when we talk about H for height, that just means the distance between the bases. Okay, a lot of kids think, oh, height, that's just like from top to bottom. Not always. For instance, if these are your bases, your height would actually be this right here. Height is the distance between the two bases. Keep that in mind. Let's skip over cylinders for now. Okay, let's look at surface area. So we have lateral area, and then we have surface area, or total surface area. It means the same thing. Okay, so this is the surface area of all the faces, including the bases. Let's take a look at this formula, which I have for you right here. Important formula number 2, write this one down. And this is where it comes from. So it says, how many bases do we have? Well, we always have 2 bases, and you can pick which ones they are. Let's say it's this one and this one. Okay, so to find the total surface area of everything, you take your lateral area, right, which is perimeter times height. We just learned that, aka L for lateral area, and you add 2 bases, 2 times B, where B, capital B, represents not just base, it means the area of a base. Okay, important formula there. Let's go ahead and look at volume. I might get cut off here in just a minute. Actually, I'll stop it here just in case I do. So going on to video 2.